Example 2.1.6, draw a single phasor diagram containing the following quantities. V1 is 5 at angle 0 degrees, V2 is 10 at angle 0 degrees, V3 is 10 at angle 30 degrees, I1 is 5 at angle 90 degrees, and I2 is 10 at angle negative 90 degrees. So to draw a phasor diagram, the first thing we need is an axis. Oh, sorry. Usually I do the givens, right? Well, in this point, all the givens is just this information right there, so I'm not going to rewrite it. The find is phasor diagram, and really the solution, that's what we're after here. Since there isn't much to do for the other two, we want to go ahead and, I'm going to leave those right there, we want to go ahead and draw an axis, right? A phasor diagram is a plot of the voltages and currents on some sort of axis. I'm going to use the real imaginary axis to plot this one. Polar plots are pretty common too. We do a couple examples of those. So to plot these, we just need to put some units on here. So I've got 10 there, 10 there, 10 there. Do your best to pretend that those are equally spaced. I know they're not, but I don't get paid enough, I guess, to draw equally spaced lines here. Okay, so we want to draw these vectors on this here. So I'm going to start with 5 at angle 0. And 5 at angle 0 is going to be equal to 5 cosine of 0 plus j 5 sine of 0, so that's 5 plus j 0 is 5 at angle 0. So I come out 5 on the real axis and up 0 on the imaginary axis. 1, 2, 3, 4, 5. So if this scale here represents 1 volt per division, I've just drawn 5 at angle 0 right there. Okay. So now I'm going to go to 10 at angle 0. I should be putting my degrees there. So that's going to be, again, 10 cosine of 0 degrees plus j sine of 0 degrees is just going to be 10 plus j 0. So now I got to come out 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, up 0 units. So that right there, I'm not going to draw over my pretty blue one there, but that vector right there from here to there is now 10 plus j 0. Moving down the list, I've got 10 at angle 30. So 10 at angle 30 degrees is going to be equal to 10 cosine of 30 plus j sine of 30. Okay, and this one's a little more interesting. We're going to get 8.66 in the positive real direction plus j 5 in the positive imaginary direction. So that's 8.66, 1, 2, 3, 4, 5, 6, 7, 8. So, about right there. And now I need to go up 5. 1, 2, 3, 4, 5. So I find where those two intersect. About like that and about like that. So they come together about right there. And so the vector representing 10 at angle 30 is that right there. And so that's 10 units from here to here, and that is angle 30 degrees. Right? So that's that vector. So now I'm going to go to the next one, which is I equals 5 at angle 90. 5 at angle 90 degrees, that's going to be equal to 5 cosine of 90 plus plus j5 sine 90. And so that's going to be equal to 0 plus j5. So this vector is going to be 1, 2, 3, 4, 5 right here. So that's that current right there. And then the last one is going to be 10 at angle negative 90. And so that's going to be equal to 10 cosine minus 90 plus J10 sine of minus 90. And so that's 10 times 0 is 0. 10 times minus 1 is minus 10, minus J10 there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there we go. I've used two different scales on this. I've used the scale that 1 division equals 1 volt. I've also used the scale that 1 division equals 1 amp. There is no requirement that you use 1 amp per division and 1 volt per division on scales. You just have to indicate it. So you would just have to write a little note here that says, 1 volt, and another little note here that says 1 amp. You just have to know what the scales are. Sometimes on these phasor diagrams, people will draw them and they'll have two different scales. So just